And our test is Friday, September 13th. So the next homework assignment, okay, this one does not have any graphing in it, because if it did, I would say you need graph paper right here. But your first homework assignment, which is homework 6, we just keep the numbers rolling. So now we're moving on to homework 6. That's due next week on Wednesday. These are the numbers that you have to do. So go ahead and glue down that first picture. Says example 1. Which of the following is a function? Who remembers the function rule? This is going back to Algebra 1. How do you know if it's a function? If you don't remember the definition, after you glue it down, you can go ahead and copy this down. This definition, it's not, that's a good definition. But my definition is no repeats in X. That's really what a function is. So that's the first thing in this next unit, is determining if it is a function, and then stating why it is or is not a function. So I'll give you a minute to glue that down, and then we will continue through that. And then in there. So let's look at these and determine if they're a function. We'll just say yes or no. So I'm looking at A. So I'm looking at my X only. Are any of these numbers that I highlighted in pink the same? No. So that means that this is a function. We would say yes. Yes, because we don't have a repeat. Now let's look at this one. Are any of those the same? So will we say yes or no? Yes. Okay, here, notice that I have a repeat. Which one repeated? 1. So what would you say? No. And you would say no. And the reason why is because, I'm not going to write the reason, I'm just going to say it. Because 1 repeats. And that's what you would say. The 1 repeats, which is why it is not a function. When you're looking at an equation, to determine if it is a function, your output, so for these 4, the output can't have an even exponent. So that's a pretty simple rule. I mean, you could make a table, but that's taking a lot of time. So the main thing is you're going to look at the output, and remember the output is Y. X is input, Y is output. There's only one of these, D, E, F, and G, that would not be a function. So which one would we say no to? G. This one is a no because it has an even exponent. This is a no, and the rest of these would be a yes. These will not have a repeat in the input. But because Y is squared, you will have a repeat in the output. Any questions about A through G? All right, let's move over. Now, these are supposed to be numbered. I don't know, but this is H. This is I. This is J. I don't know if yours is numbered or not, but for H, this is called a map. The first oval is your input. The second oval is your output. So the one thing I want you to notice is every single output is only going to, every single input is only going to one output. So you see how every single, even though I don't know what these are, it's just dots. It doesn't matter what they are. Every single one of these points is only going to one output. That means that that is a function. This is a yes. The way you can tell that I is a no is because of this one right here. Okay? That one input has two different outputs. It's going to two different outputs, which makes that one a no. That's your map. Lastly, a graph. So have you guys heard of the vertical line test? So if it fails the vertical line test, it's a no.
Is that if like it crosses the line twice?
Right. So for example, in this first graph, if I draw a vertical line, how many times did that green line go through the graph? One time. So that means it passed it. So this would be a function.
But it wouldn't be a one-to-one, right?
It wouldn't be one-to-one, you're correct, because it has to pass a horizontal line test to be one-to-one. I don't think we talk about that though. I don't remember. But yes. But for a function, this would be a yes. Okay. But for a circle, this is a no because that vertical line, you see it crosses through twice. That means it failed the test. So that would be a no. All right. So that's the first thing in this first chapter is you have to be able to tell me if it is a function, and it could be given to you as a graph, an equation, a map, or an ordered pair, set of ordered pairs. All right, the second thing we're going to talk about is our domain test. So go ahead and glue this down. I didn't want you to copy it down, so go ahead and glue down that second handout. I like to think of these as red lights. So every single function starts out with a domain of all real numbers. And I know mine might look a little different from yours, but every single function starts off with a domain of all real numbers. Everything is an interval notation. I should also say that. Oh, no, it's the same. So we start off with all real numbers, okay? And we stay with all real numbers unless we hit one of these red lights. I like to call them a red light because that's when we got to stop. The first red light is if you have an X in your denominator. You cannot divide by 0. If you pick up a calculator right now and you pick any number and divide it by 0, you're going to get an error. That's your first red light. The second red light is a square root. Because you cannot take the square root of a negative, okay? So we're going to spend the rest of today just finding the domain. We're going to practice finding the domain. That's it. So again, unless you, and you need to memorize these two red lights, a variable in the denominator and a square root. I gave you an example. This would not be all real numbers. But if I were to say x minus 2 over 3, that's okay. That has a domain of all real numbers because there's a 3 in the denominator, not an x. It's the x that changes the domain, okay, the variable. So we're going to just do some practice finding our domain of different equations, and then we will end there for today and then pick up with the rest on Monday. So we have A, B, C. We got 9 questions that we're going to find a domain. That's all we're going to do. We're not graphing. We're just going to find a domain. So go ahead and copy down these first 3, A, B, and C. And we're just gonna state the domain. That's all you have to do. All right, we have all three copied down. Raise your hand if you're still writing. Okay. So remember, you're looking for a red light. If you don't see a red light, that means it's green. It's all real numbers. And our two red lights are a variable in the denominator and a square root. So what about A? Do you see a red light in equation A? So our domain is all real numbers. No reason to stop. Our domain is all real numbers. What about B? Do we have a red light? A square root.
Yes.
What's our red light?
Oh, square, just,
Yeah, I don't see it, because let's go back to our red lights. A red light would be a square root. Not a square root. Okay? So do we see a red light in the second equation? So our domain would be all real numbers. Now in C, we do have a red light. We have a square root. You cannot take the square root of a negative, which means that this has to be greater than or equal to 0. So whenever you see a square root, only take what's underneath the square root, which is 3x plus 2, and you're going to make that greater than or equal to 0. Solve that inequality. Only what's underneath the square root. So if there were a number in front or behind it, that doesn't matter. It's only what's underneath the square root. So let's solve that for x. Leave our answer as a fraction. We're going to subtract the 2 and divide by 3. Do I need to flip my inequality? No, because I divided by a positive. So this means x has to be my domain. This is my domain right here. But in pre-calc, we need to write that in interval notation. So it's greater than or equal to negative 2/3. So it would be a bracket on the negative 2/3, and it's going towards infinity because it's greater than. This is the acceptable way to give me the domain in anything. A lot of you all did not, for some of you all, lost points on the test because you didn't write your answer in interval notation. Everything we do is in interval notation. Everything. All right, any questions about C?
no.
3 more. Let's go to the next 3. Copy down D, E, and F. Sorry, let me zoom in for that last one. All right, so let's look at that first one. Let's look at D. Do we have a red light? Yes or no? Yes. So this red light is a variable in our denominator. So when you see a variable in your denominator, this cannot equal 0 because you cannot divide by 0. So x minus 1 cannot equal 0. And if x minus 1 cannot equal 0, that means that x cannot equal 1. So on the number line, let me go ahead and make a little number line. That means at the 1, we have to hop over the 1. There's an open circle. So our domain has 2 intervals. This is my first interval, and this is my second interval. So my first interval would be negative infinity to 1, but remember, it can't equal 1. So am I going to put a parentheses or a bracket on the 1? Parentheses, because it can't equal 1. Now, because there's a break, we're going to put a U. That means union. And then we're going to do the second piece, 1 to infinity. This is how you say all real numbers except 1 in interval notation. That would be my domain. That is what I'm looking for. So you can't divide by 0. So pick up a calculator, pick up any calculator, and take 5 divided by 0. And it's going to tell you it's a domain error, I think. I don't know if it says what it says. But okay. Well, for this one, it says divide by 0 error. You can't divide by 0. It's mathematically impossible. All right, let's look at E. E, when we set that, remember, x squared minus 9 cannot equal 0, which means x squared cannot equal 9, which means x cannot equal what? Not just 3, but there's 2 numbers it can't equal.
Negative 3 and 3.
So there's 2 numbers we got to take out. So that's going to take our domain and chop it into 3 pieces. So let's make our little number line. So we got 2 open circles here and here. So I have to write this piece, then this piece, and then this piece. So my domain is now chopped into 3 sections. So for my first section, it would be negative infinity to negative 3 parentheses, union. And then my green piece would be negative 3 to 3, union. And then my pink piece would be positive 3 to infinity. And that is my domain. My domain had to be chopped into 3 pieces. Yes?
When you was doing the second step, like you went from 0 to 9 to plus minus 3, how did you get there?
How did I get from here to here? So I took the square root.
Oh,
Yeah, I just solved it. And the square root of 9 would be positive or negative 3. Any questions? So far, we okay? Okay, now let's look at F. F is a double whammy because it has 2 red lights. Here, let me go ahead and extend my page. There we go. We have 2 red lights. So there's 2 things. And normally, we would say this has to be, normally, it has to be greater than or equal to 0. But because it's in my denominator, what do you think I have to write it? Instead of greater than and equal to 0, it's just greater than 0. Because we have 2 red lights in one. I put both red lights in one equation. So not only do we have an x in our denominator, we also have a square root. So we need to rewrite our inequality. So we're going to write x plus 5. It has to be greater than 0. It can't even equal 0 this time. When you subtract the 5, x has to be greater than negative 5. Go ahead and write that in interval notation. So because it's not equal to, we have a parentheses on both sides. -5 to infinity, and that would be your domain.
Did you flip that to be infinity -5 or
No.
So what's the,
So that's a good question. Whenever you write interval notation, it's always the smallest number first to the largest number. So what's smaller, -5 or infinity? So -5 has to come first. Good question. All right, last three, y'all. Go ahead and copy these three down. Oh, sorry, I didn't mean to zoom in like that and tell you how to copy all three down. So again, if you don't see a red light, it's all real numbers. Do we have a red light in G?
yeah.
So it's a square root. So what's underneath the square root has to be greater than or equal to 0. So this one here, this has nothing to do with the domain. I don't care about that, and I don't care about that. The only thing I'm looking at is what's under the square root. So we're going to take that -4x plus 1. It's not in the denominator of a fraction, so it has to be greater than or equal to 0. Go ahead and solve that for x. Yeah, we have a fraction. Leave it as a fraction. Fractions are good. So we subtract the 1. And now I have to divide by a negative. And when you divide an inequality by a negative, what do you have to do with the inequality? Flip it. So x is less than or equal to positive 1/4, because a negative divided by a negative is positive. So this is less than. So that means my domain would be negative infinity to 1/4 with a bracket. That's the domain I'm looking for on our next quiz. I think we got a skills check next week, but we'll talk about that Monday because I can't think about that right now. All right, H. Do we have a red light in H? Do you see a denominator with an x in it? Do you see a square root? So what's our domain? All real numbers, yeah. No restriction there. And then last one for today. Let's look at question I. So there's two different equations that we have to solve for x. X plus 1 cannot equal 0. X minus 4 cannot equal 0. So there are two numbers that I need to exclude from the domain. For the first one, I'm going to subtract 1, which means x cannot equal -1. For the second one, I'm going to add 4, which means x cannot equal +4. So I'm going to make my number line just because I think it's helpful for these types of equations when there's a variable. So I have -1 here and +4 here. These two numbers have to go. So I need to break my domain into 3 pieces, just like we had to do for one of the previous questions. This is my first piece of my domain. This is my second piece. This is my third piece. Everything gets a parentheses. Nothing gets a bracket because it cannot equal. Okay? So the first segment of your domain, the first piece will be negative infinity to -1 parentheses union. -1 to 4 parentheses union. 4 to infinity parentheses. Okay, we're going to end there. Feel free to start working on homework 6 now or start working on your sub assignment so you can get that out the way.